Hi everyone, I hope you are all feeling good today. We meet again. Okay, here, the video will explain how to determine the deflection of beam using Macaulay method. From previous video, the deflection of beam using integration method. We saw when a new load introduced along the beam, the moment equation changes. So we need a separate elastic curves equation to fully define the beam. That's pretty tedious, isn't it? Fortunately, we have what we call discontinuity functions that allow us to have an elastic curve that fully define the beam. This means, we just using a single expression or what we call internal moment equation, regardless the number of loadings. This method called Macaulay method. The purpose of Macaulay method is to describe distributed loading, or what we can call Macaulay bracket. These form can be written in general form when the distance x moves past where the load is applied. This bracket is to distinguish it from ordinary function, x minus a, power of n, written with parentheses. As stated by the equation, only when x more or equal than a, this will give a value, otherwise it is 0. This show the integration of Macaulay functions. To illustrate it how it works, I'll show you quick. This figure show cantilever beam with 2-point load. This example is the same cantilever beam as used in the integration method video. Using Macaulay method, we'll attempt to get the moment equation. Using this method we only need to cut section at the end of beam section. For example, x more or equal to 2, which is the moment equation, is minus px minus p times x minus 2. This is other example for cantilever beam. The cantilever beam is loaded with UDL, point moment, and point load. Remember, using Macaulay method, we cut at the end of section. In this case, since the distributed loading does not extend to C as required, we will use superposition of loadings to represent the same effect. Here is the formula for different types of loading, since we just want to determine the moment equation. So we just focus on the column for the moment equation. There is different loading: point moment, point load, UDL and triangular load. Procedure analysis for the deflection using Macaulay method. The procedure is same as integration method. First, sketch the free body diagram of the beam and establish the x and y coordinates. Then, calculate the support reactions and write the moment equation as a function of the x coordinate. Then, substitute the moment expression into the equation of the elastic curve and integrate once to obtain the slope. Integrate again to obtain the deflection in the beam. Then, using the boundary conditions, determine the integration constants and substitute them into the equations obtained in step 3, to obtain the slope and the deflection of the beam. When computing the slope or deflection at any point on the beam, discard the quantity, x minus a, from the equation for slope or deflection if it is negative. If x minus a is positive, it remains in the equation. To understand more detail, let's look at the next video for the example of deflection using Macaulay method. Thank you for watching this video.